Okay, so a lot of people have had questions in class, so I'm going to try to do this to explain stuff. So let's just start off with picture in mind, like maybe, one of these three-dimensional XYZ things. Maybe you can just think of it as like X1, X2, X3, but you'll see why there's like confusion for sure. Um, which will be explained. So we'll have this vector 1, 0, 0. We'll call it A1, little hat. And then this will be another vector. This will be 0, 0, 1. We'll call it A2. And let's say there's like this target vector we want to have. And this one's going to be 1, 0, 2 equals B, right? And so we do our thing where we make an augmented, or I mean, we could write it as a vector equation, right? In the textbook and in the quizzes and in the like everywhere they write it like this: plus x2. Oh wait, yeah, equals, right? Don't they write it like that? And you could also get the coefficient matrix, or I mean the augmented matrix, right? And then we can do a row swap here, and then it's already reduced. 0, 1, 2. I'm gonna put the little line there. And then, so you'll solve this, right? You'll take that to mean x1 is equal to 1, and x2 is equal to 2, right? Maybe say, oh, there's an x1 here and there's x2. There's no x3 column, right? There's row zeros. Maybe you're wondering about that, but just stick with me. So then you'll know that you can write the solution as, okay, you can write it as 1, 1, 0, 0, plus 2, 0, 0, 1 is equal to 1, 0, 2. Okay, and then there's like questions about like uniqueness versus infinite solutions versus span. So what I just want to explain is that I think it's confusing that we started off with these vectors, right? 1, 0, 0. We started off with this vector 0, 0, 1, right? And we put it into this vector form. So this is A1. Sorry, this is A2. This is B, right? And we put them into this matrix, and then we solve for it, and we get our pivots. And then we know that that means our coefficients are x1 and x2. What I just find is confusing is that they use variables x1 and x2 for coefficients. Because x1 and x2 kind of sound like they belong as like axes, like x1, x2, x3, but they're actually not. They're just coefficients. And so that's my first thing, just to like try to mentally recognize that when they do stuff like that and ask you to find x1, x2, and all that, they're just coefficients. The other thing that I could try to explain is how I view the matrix. So we take our vector A1 and we place it here, right? You might be wondering, why is it downwards, And then we place A2 here, and then B here. And then we do row operations. The reason why the matrix, and let me split these up. The reason why we place the things in the matrix like this are because, let's say for our vector, this is 1 in the I hat direction, this is 0 in the J hat direction, this is 0 in the K hat direction, right? We place the vectors downwards like this, so all the I hat numbers line up on this row. All the J hat numbers line up on this row, all the K hat numbers line up on this row. And yeah, I mean, you could look at it like here. We had the vectors 1, 0, 0. I'll put it up here. Then we had the other vector 0, 0, 1. 1. You're gonna just start looking at it like downwards, because these are the I hat numbers, these are the J hat numbers, these are the K hat numbers. And then where's our target? 102. 102. So then you'll notice when we put the vectors downwards like this, what we end up getting is across, we get all the I hat numbers lined up. These are all the I hat numbers, 101, 01, 000, 000, 000, and then downwards, right? Sorry, all the K hat numbers are lined up. When we take our vectors, put them downwards in this matrix, what happens is all the K hats, like these are the K hats, these are the J hats, right? All of them will line up, 0, 1, 2. Okay, and that makes sense because then when we solve for C1 and C2, it works out that C1 times all of these directions add up to our target B. I kind of want to say, like, how do we know that these pivots equal the coefficients here? Which I think is the most confusing part, that when we're solving for like these pivots and stuff, and then when we write our general solution, right? C1, we're actually solving for coefficients. All right, and if we had a more complex system of equations, if it was like x1 equals 2/3 x2 plus 3x3, x2 equals I don't know, x2x3, and then x3 is free, then we're like, yeah, this is our system of equations, and then we write it as like I don't want to get confused, but anyway, these are coefficients, and they're x1 and x2 and x3, which kind of makes you think like spatial variables, but they're not. They're literally coefficients, and I think that's what's like the most confusing thing. So let's just get into uniqueness and whatnot, and this, because I can say that quick. But anyways, you lined up your vectors, right? And you row reduce it, and you just get to a point where you have it as like, okay, I have only this number to worry about. My system, right? My system has been reduced to this, right? And maybe you're thinking, well, does it matter when I swap rows and whatnot? No. When you swap rows and shit, it doesn't matter, because at the end of the day, what we're finding is C1 and C2. We're finding coefficients, and we're not literally like we're not deriving any results that depend on a direction like X, Y, or Z, or I hat, or J hat, or K hat. We're just taking this matrix, right? This tool, and we're finding things like this, which define a system of equations for our coefficients, I mean, I just got it when I thought about it for a while. Like, you swap these, and like, it doesn't make a difference. It just doesn't. Anyways, whatever. We use matrix to find coefficients. And then, what about the whole like uniqueness existence thing, right? Let me just take 2 examples from the book real quick. So here's example 1. There's like a matrix 3, 4, 2, -9, 12, -6. Sorry. -3, 4, -2, 0. And then we row reduce it all the way to 3, 4, 2, 0. And then zeros everywhere. Okay, so what can we say about this, right? We have it that the system of equations or whatever would have it that 3x1 plus 4x2, again, which is confusing because it's using x1s and x2s, but these are coefficients. Okay, coefficients that apply to vectors, x1 times 3, -9, -3 plus x2, blah, 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 blah. equals 0, 0, 0, right? So here's our system of equations, and then you might be wondering, like, so then the rows of zeros, okay? This is x1. Again, it's a coefficient. It's not a variable or anything like that. It's not like a directional thing. And then this is x2 and this is x3. So we know we have our pivot here. No pivot in row 2. Sorry, no pivot in column 2. No pivots. All right, no pivots. That means that x2 and x3 are free. x2 is free. x3 is free. Sorry, plus x3. So we maybe wonder, does this mean we have infinite solutions or unique solutions? I'd say that here's something you should pay attention about. When we're saying unique versus infinite solutions, we're talking about a specific B. Okay, in this case, our B, like our target as the sum of our vectors, was 0, 0, 0, 0. So does this have unique versus infinite, like unique or infinite solutions for this particular B? It has infinite solutions because, well, x1 depends on x2 and x3. Like x1 comes last after we decide what x2 and x3 are. So because these are free, we pick whatever we want, 5, 1, and then x1 will depend on x2 and x3, right? But that means you have an infinite combinations of coefficients x1, x2, and x3 that you could add up, right? That you could add up to get B. So we'll say that's infinite here, right? When would it be unique? Unique would be you have no free variables. Okay, so what about the whole when there's a pivot position in every row, or like here's the next thing that I'll try to say. Hopefully you can find like a example where there's like okay, well, we'll just have to, all right, let's just make this one. Okay, 0, 3, okay, 4, 5. Okay, now here comes the question. So I shouldn't have drawn it like this, sorry. I actually drew this wrong just because I made this up and I took it from an example. And okay, this is our matrix now, right? Our augmented matrix. Here's our A1. These are our vectors. This is a target vector, and we're trying to row reduce it. Hey, look, it's already row reduced, so we know that this pivot. So we have our pivots in each column, and we can get our system of equations or whatever. So we'll have that x1 plus 2x2 is equal to 4, or that 3x2 is equal to 5. So we'll have, right, because I have to just do this at this point, 5, 3, and then x1 is whatever it is. So again, we might go into unique versus infinite. Okay, and again, that's about a particular B, right? For this B, we don't have any free variables, so there's only one combination of our coefficients that can get us B. So this one will be unique, okay? And then we might say, does the matrix A, or we might say, do all B exist in the span of A? Okay, what this is asking is, can we get any solution? Okay, can we get any solution for any b? Okay, and the answer to that is yes, if we have a pivot in every row. And this will be kind of rambly, but just picture this. This is our b. What if we swapped it out for 5, 4? No problem. We can make, 3x equal 4. We can solve for it. We'll get a new coefficient, right? What if it was 0, 0? No problem. We'll get some new coefficients, right? So for any b, we will have a solution, right? If we had if I don't want to get us confused, but you know the difference now, okay, right? From like unique versus infinite comes down to having a free variable that can get you like an infinite number of combinations of coefficients of these vectors to get this target vector. Now, when we're talking about like, do these vectors span the whole space of R2, right? Can you get any b from your vectors, right? Whatever I said earlier, like, which is a slightly different question. Yes, we can get any b if we have a pivot in every row, because then you could do, like, it just doesn't matter. We could put 1, 0 here, and x2 is going to be 0, and x1 is going to be 1. Like, it just doesn't matter. Does it have infinite solutions? That would come down to having a free variable. And then when does it not have infinite solutions? Well, it's really simple, really. So 4, here's 0, 5. Anytime, okay, let's say if you have this augmented matrix, this doesn't have, like, we cannot get b. We cannot get, I'm gonna try to fucking wrap this up without writing, I'm sorry. Okay, because I just don't have the patience for this. But we can't get b from a combination of our vectors a1 and a2, because we have this thing down here, which would turn out to be like 0, x1 plus 0, x2 is equal to 5. There's no way we could ever make that happen, right? So for this specific b, no solution. What about for all b? You can start asking questions, like you can start, maybe at this point you can start understanding. For all b, I mean, only b's like where like this comes out to 0, but that's not really it would only work out when this comes out to 0, but that's not all b, right? It would, so for this b, right? And then, yeah, what if it was, now we're just like right off the bat, like what if it was just like that? And what if we had a thing of zeros, right? We have one pivot, right? What we could say about this is that x2 is free, okay? x1 plus 2x2 is equal to 4, x2 equals free. So what we could say about, we could say about this is that we would have, I mean, what do you think we could say about it? But here's what we could say about it. We would say that we have an infinite number of solutions for this b. So this would be infinite for b. Because we can make x2 whatever we want, and x1 would depend on our free variables, and we could get to b in an infinite number of combinations for b. But does a solution exist for all b? No. Because what if you swapped out, because when you row reduce and you swap rows and shit, like everything stays in its column. Like, it doesn't matter what this is. This could be 20 and fucking 10. And it's not going to affect the row operations that happen over here. So you're going to end up always with a 0, 0 here. And there could be some B's that don't have a 0 here, like this 10. And that would give you an inconsistent, you know, expression. So, no, it would be inconsistent for some B. Okay, so for some B, so the only way that there exists a solution for all B is that there has to be a pivot in every row. Pivot in every row, okay? Pivot in every row. It has to be, because if this were a pivot, it doesn't matter what the fuck this is, because we could always make it work out, okay? And if there were some free variables, then that could mean you know an infinite common, like you have infinite solutions for infinite like target vectors or whatever. So I think I did a good job of explaining it, and that's all I had. So yeah. Oh shit, you guys couldn't see the bottom. Okay, well there's the bottom.